So the purpose of this particular exercise is to implement this algorithm that we see here, which takes a matrix A and sets it equal to the identity matrix. And we're just going to assume that matrix A, when it comes in, is a square matrix, since otherwise the identity matrix doesn't really make sense. So how do we do this? Well, we open up the Spark web page. This time let's call this routine set to identity, and as always it needs to be an unblocked algorithm, and let's leave the variant number alone, and we only have one matrix. Now in this particular case we're going to march through the matrix from the top left to the bottom right. And why is that? Well, it's because initially a top left is a 0, 0 matrix, and when we're all done, it is the entire matrix. So we're slowly going to sweep through the matrix, expanding the top left quadrant by one row and one column at a time. To do that, over here, we pick the direction to be top left to bottom right, which happens to be the default. And again, we want to make A both input and output, and choose as output language Matlab. And then on the right we get our code skeleton. And then we cut and paste that into a Matlab session. So we say new function, and that gives us this window to work in. Let's make it a little bit bigger. We'll highlight all of this and wipe it out, and then we will paste our code skeleton in there. Let's make this a little bit bigger. Let's move this over a little bit. Okay, so if you put this next to the algorithm, then you will notice the similarities. And now all we need to do is erase this and set A01 equal to lav 0 vector of A01. And then we could set alpha 11 equal to 1 and A21 equal to lav 0 vector of A21. And then we want to save that. So we can click on save. And then we may want to save that as set to identity, unblocked. And now we can see what happens if we create a matrix and call this routine. So we may want to say A is equal to a random integer matrix with values in the range from -2 to 2 of size 4 by 4. And that gives us a square matrix. And then we call the function set to identity unblocked of A, and we get the identity matrix back. Now let's see what happens if we put this particular function into picture frame. So we open picture frame, and then we take all of this, then we take everything in this window and we wipe it out, and then we insert the function that we just wrote, and we say load program, and then we say next, and in red it highlights the part of the code that's being executed, and on the right you see that A top left is empty. If you say next, it checks whether we're done, which we're not, then it repartitions, and then it sets A01 to the 0 vector, but notice that A01 is sitting up here and is actually an empty vector. And then it says next, and what it does is it gives you a warning saying please use the lav functions. Now the problem here is that it doesn't understand how to assign 1 to a variable. So what we have to do is click on new program, and instead of setting alpha 11 to 1, we are going to use the lav function 1v, which sets a vector to all ones, but notice that alpha 11 is just a special case of a vector that happens to only have one element. Then we can click Load Program again, and we can restart. And now it sets the entry on the diagonal to 1, and then sets all the entries below it to 0. And then it moves forward. It's at the end of the loop. And then it goes back to the top of the loop. It checks whether it's done, repartitions, sets A01 to 0, which now has one element, sets the element on the diagonal to 1, everything below it to 0, etc. And we're done. Okay. So now we can demonstrate that there can be different algorithmic variants. So let's click New Program. And let's see what happens if we try to set the matrix to the identity one row at a time. So that would mean that we would want to set A10 transpose to 0, alpha 11 to 1, and then A12 transpose to 0. So how would we do that? We would do this right here. Then we would still set that to 1, and then we would set A12 transpose to 2 zeros. And then if we say Load Program and say Next, we notice that now we set the matrix to the identity one row at a time. And so forth. But that's not the only other algorithm that exists. We could also say, in each iteration, assume that this has already been set to the identity. It's now set A01 and A10 transpose to 0, and set alpha 11 to 1. How would we do that? Well, we would do this right here, and we would set this to the 0 vector. And now if we say Next, what we notice is that first we set that to 1, then we move forward, and now we see that these parts are being set to 0, 1, and 0 respectively. We move forward, we repartition, we set that to 0, to 1, and to 0, and we move forward. All of a sudden you notice that there are several algorithms for setting a matrix to the identity. I suspect you can probably think of one more. Anyway, the whole point here is that, number one, the way we code makes it very easy to experiment with this, and number two, this picture frame tool makes it really easy to visualize what's going on.